Okay, we are going to do another problem using the four-step process, and let's figure out what this question is asking. We have a handbag company that's trying to decide whether to redesign one of its bags. Customers have to pay more for the upgraded version. For the redesign to be profitable, the company needs to sell it to more than 20% of their current customers. You contact a random sample of 60 customers and find that 16 would be willing to purchase the redesign for more money. Do the sample data give good evidence that more than 20% of the company's customers are willing to purchase the redesign? Carry out an appropriate test at the alpha equals 0.05 level of significance. We've got some key indicators here. We are asked to carry out a test. This means no interval. We want a test. So it's a hypothesis test. And are we talking about percents or are we talking about averages? We are talking about this 20% here, which means it's a proportions question. And we're only dealing with one sample because we have this one sample of 60 customers. We don't have two. So this is a one sample hypothesis test for population proportions. What do we need? In our state, we need our null and our alternative hypothesis in symbols. We need to define our parameter in context, and we need to state our alpha level. So we want to perform a test at what significance level? Now, the null and the alternative. We decided we were talking about percents, and so that means that our parameter is p. We're going to be dealing with proportions. Our null is always an equality statement. And then we are going to determine what our direction is based on what the claim is asking. The question says, do the sample data give good evidence that more than, that's a greater than, 20% are willing to purchase? That tells us our value that we're talking about as well. So we're dealing with more than, and we're dealing with 20%. I need to define P, where P is the true population proportion value of company customers that are willing to purchase the redesign. Let's double check and make sure we have everything. Do we have the symbolic statement of the null and the alternative hypothesis with the appropriate parameter? Yes, we have the null with the alternative, we have the parameter here, and we have the hypothesized value. Do we have the parameter in context? Yes, we do here with this P here, and then we have our level of significance. Now we can move on to the plan where we check our conditions. Checking your conditions for a hypothesis test are going to be similar to checking for a confidence interval. If you're dealing with proportions, we talk about random, we talk about independent, and we talk about normal. First of all, is the random sample? Yes, you contact a random sample of 60 customers. So the sample was random as stated. Now we need independent. This does not give us a population size. So we need to assume that 60 is less than 10% of the population of customers. That means that we need to at least have 600 customers, which is safe to assume. When you're checking normal for a population proportion confidence interval, we used p hat because we don't know the assumed proportion value. But for a test, we use n and p. We do not use p hat here. So our successes and failures need to be with the population value here. This means we have 60 times 0.2, which is 12, definitely greater than 10. And then our failures is going to be 80% or 0.8, which is 48, which is also greater than 10. So our conditions are met. We've checked the random, we've checked the independent being less than 10% of the population, and we've checked both successes and failures. So we can now move on to our do, where we're going to run the numbers. And when you're doing a hypothesis test, again, it's similar to where you would go in StatCrunch for the confidence interval. You go to proportion stats, one sample with summary. And remember, we use with summary because I'm not giving you a list of data. If you had a list of data, then you would use with data. Now, the number of successes we had in our sample is 16 out of 60. We write down our p hat, which is 16 out of 60. We write our sample size of 60, and then we calculate our z-test statistic and our p-value. With 16 successes and 60 observations, that comes from our sample, 16 in our sample were a yes out of the 60, we get a z-score of 1.291, which has a corresponding probability or p-value of 0.098. And this is when we have the null hypothesis being equal to 0.2 and our alternative is being greater than 0.2 from above. So let's double check and make sure we have everything that we need in our rubric. We have our p hat value, we have our n value, we have our z-score, and we have our p-value. And now we need to conclude. We want to connect our alpha level of significance to our p-value because that's going to tell us whether we have evidence or not. And our chosen level of significance here was 0.05. So we're going to make our conclusion based on how the rubric guides us. We conclude by saying since our p-value of 0.098 is not less than our alpha equals 0.05, since 9% is bigger than 5%, it is not less than our level of significance, we're going to fail to reject the null. There is not evidence to support the claim that more than 20% of the company's customers are willing to purchase the redesigned bag. So let's see how that looks. Now, when our probability is higher, this just means that if our null is assumed to be true, then it's not really likely or it's not really rare that we get these values. When our p-value is small, that means that if our null was true, then the likelihood of getting the values that we got are rare. So a small probability means that if the null really was true, then it's rare that we got these numbers. That's evidence to say that the null is probably not true. So here we say our p-value is not less than our alpha level of significance, so we're failing to reject the null. And if we're not rejecting the null, then there isn't evidence for the claim, which is the alternative. And we say it here in context. And the way that I worded it is I said that more than 20% of the company's customers are there is insufficient evidence to support the claim that more than 20% of the company's customers are willing to purchase the more expensive redesigned bag. You just want to make sure that you're not saying we fail to reject the null, there's insufficient evidence to support the claim. What's the claim? Give me context here. So making sure in our conclusion we have what we need. We stated our p-value, we stated our alpha level of significance, we linked it with not less than, we said that we failed to reject the null, that there was insufficient evidence, and then we gave it context here. And that is how we finalize the hypothesis test for confidence intervals.